Hello students. We are going to now start with a very important concept. That is your lecture number 4 of the topic, some basic concepts. This topic will introduce you to some very basic concepts of chemistry that is called atomic mass and molecular mass. So let us begin with the topic. Let us begin with the concept of atomic mass. As you know, atom is the smallest particle of an element. And since atom is very, very small, its mass also is going to be extremely tiny. You know, it is modern day science which has introduced an instrument called mass spectrometer. Because of this instrument, mass spectrometer, we are able to measure mass of the atom with very great accuracy to the extent of 10 raised to minus 24 gram is the extent by which we can measure the masses. But you know, in earlier days, there was no such instrument available. So they used to find the atomic mass using what is known as relative method. It was established by so many scientists that hydrogen has only one proton. Hydrogen has only one proton. Hydrogen has only one electron, and there is no neutron. All the mass of an atom is because of the proton and neutron and not because of the electron. So they said, if an atom, hydrogen atom, has only one proton, let us take the mass of hydrogen as 1. They did not know the unit of it. And being atom as a very tiny entity, you cannot call it as gram and kilogram. So they just called hydrogen equal to 1. This was arbitrarily given a number to hydrogen. Nobody knew whether this number was correct or wrong. They just said 1 proton, that's why atomic mass is 1. Considering this hydrogen's atomic mass, they started assigning atomic masses to the other one. That is why this is called relative method. As science progressed, they came to know that better than hydrogen, we can make use of other element. And when SI system was established, they chose carbon 12 as an isotope. So now a standard considered is carbon 12 and not hydrogen. This carbon 12 is now assigned a mass 12 atomic mass unit, which is usually called AMU, atomic mass unit. The question is, what is AMU? How do we define it? So it is defined as 1 atomic mass unit is equal to 1 upon 12 mass of 1 carbon 12 atom. 1/12 the mass of carbon 12. Let us analyze this more a little bit. What is mass of 1 carbon 12? It contains basically 12 protons plus neutrons. Now, protons plus neutrons are called nucleons. So I can say 12 protons plus neutrons or 12 nucleons. So instead of saying mass of 12 nucleons, we can say 12 into mass of 1 nucleon. Simple mathematics will tell you this 12 and this 12 cancels. So what you get is 1 AMU as mass of 1 nucleon. So the original definition was based on actually carbon, but now easier definition is very simple, just mass of 1 nucleon. This nucleon could be proton plus neutron total. So finally, the mass of 1 AMU is now considered as 1.66 into 10 raised to minus 24 gram, or converting into kilogram, 1.66 into 10 raised to minus 27 kilogram. So for you understanding, and if you are making your own notes, writing 1 AMU definition is very important. Remembering 1 AMU in gram is very, very important. Let us go ahead, dwell more into this. Let us solve a small numerical problem which was asked in MHT-CET earlier, and let us see how the problem goes ahead. They have given us mass of an oxygen atom in the unit of gram. They want to convert it in the unit of U. So what can we write over here? We know a standard relation, 1.66 into 10 raised to minus 24 gram is considered as 1 U. So 25.56896 into 10 raised to minus 24 gram would be how many U? So cross multiplying this, 25.56896 into 10 raised to minus 24, the whole thing divided by 1.66 10 raised to minus 24. This gives you an answer 16 U. That means this amount is equal to 16 U, which we call as atomic mass of an atom. So this is atomic mass of oxygen we have calculated. So we summarize once again. If you want to calculate mass of atom is given in gram, divided by the constant 1.66 10 raised to minus 24. If you find that this division is going to be difficult for you, let me give a shortcut. Whenever you are having 1.66 into 10 raised to minus 24 as denominator, this number comes out to be 6.022 into 10 raised to 23. So the same problem could be solved in a different way as 25.56896 into 10 raised to minus 24 multiplied by 6.022 10 raised to 23, and try that calculation, you will get the same answer. This becomes an alternate method. More important for you, reciprocal of the AMU value, you should remember by heart. Some of you might be knowing this particular number is called Avogadro number. But we will come to that little later, maybe in the next lecture. Let us focus today on atomic and molecular masses. Let us come back to this unit concept of atomic mass. Now, mass of atom, as we said, was earlier by hydrogen. That was the oldest method. In between, it was replaced with oxygen. Now with SI system, finally we have landed with carbon. So if so many different units were there, they said finally, instead of calling it an atomic mass unit, let us call it with a new unit called unified mass, just written as U. So giving an example, atomic mass of hydrogen is 1 U. Atomic mass of oxygen is 16 U, and so on. So as in school, you were calling the units as AMU, the old system. The modern system is to write unit with U, not AMU. SI system accepts that unit. The question is, we told on the very first page, relative atomic mass. You are finding something with respect to carbon. How do you find that? Let us understand it. Relative atomic mass is found as mass of one atom of element divided by 1 upon 12 mass of one carbon-12 atom. Think about it again. In numerator, we are keeping mass of that element. In denominator, we are dividing it by 1/12 the mass of carbon-12. Let us think more in detail about this. What is mass of one atom? We already told. It is the mass of proton plus neutrons. That's nucleons. So changing this equation to mass of one nucleon into number of nucleons. Think about this equation again. This 12 cancel with this 12. Mass of nucleon cancels with mass of nucleon. What is finally left over is simply number of nucleons. So now we settle with an easier equation, easier meaning. Relative atomic mass is nothing but number of nucleons. Relative atomic mass is equal to number of nucleons. What is number of nucleons basically, in case you have forgotten? It is nothing but atomic mass number of an atom. For example, when I say oxygen 16, this atomic mass number itself is called number of nucleons. So if I give you this example itself, what is relative atomic mass of oxygen? Answer is very simple. It is merely 16. Let us take up some more examples upon this. Before that, we will define one more thing. Atomic mass. Remember, I go back again. The term was relative atomic mass. Now I am coming to atomic mass. And what is it? Mass of an atom, of an element taken as atomic mass. So, atomic mass is equal to relative atomic mass multiplied by AMU. But what is AMU? 1.66 into 10 raised to minus 24 gram. So, if you are actually finding this answer, this is called atomic mass. But usually, although I have shown it like a multiplied, they never do that. They just write U in place of this thing. So instead of this entire number of 1.66 10 raised to minus 24, they just mention U. We will see that in the examples also. Coming to the next point, we will take a short detour to understand what is mole concept. You know, 1 mole of a substance contains Avogadro number of particles. By particles, we mean either atoms, molecules, ions, anything. So 1 mole, I repeat, is 6.022 into 10 raised to 23. Keep that in mind and let us use it. We now define what is known as gram atomic mass. And what is that? Atomic mass of 1 mole of atoms. Very, very important thing. Atomic mass of 1 mole of atoms is known by the name gram atomic mass. People usually write it as GAM. May not be clear. We will explain it with an example. Consider oxygen 16. Now focus, very, very important. Consider oxygen 16. You can see its number of nucleons is clearly given to you as 16. So, what is relative atomic mass of it? Number of nucleons, 16. What is atomic mass of it? 16 into 1.66 10 raised to minus 24, or simply write as 16 AMU, or even in modern sense you can write 16U. Now they ask you what is gram atomic mass. So we said atomic mass of 1 mole. But how much 1 mole is? Isn't it Avogadro number? Now let us multiply this whole thing. And this answer comes as 0.999, which we take as 1. So in other words, all this entire stuff what you see is nothing but just a number 1. So my answer becomes 16 gram per mole. So the unit of gram atomic mass is 16 gram per mole. So let us summarize before we solve practice problems. if they give you an isotope O16, writing merely 16 without unit is relative atomic mass. Writing 16 with AMU or U is called atomic mass. And writing 16 with a unit gram per mole is called gram atomic mass. Everywhere number 16 remains, only the units keep on changing. I hope a very important concept is clear. These are some of the atomic masses given to you in NCERT. We are going to use them in the problems. So you need not by heart everything of it, but as you practice, you should keep some of the numbers in mind. So let us begin. Here we have been given some elements over here and their atomic mass nucleons is given. So let us fill up the table. Relative atomic mass is going to be 1. Atomic mass is going to be 1 U. Gram atomic mass is going to be 1 gram per mole. So for carbon, it's going to be 12. 12 U. 12 gram per mole. For nitrogen, it's going to be 14. 14 U. 14 gram per mole. For oxygen, 16. 16 U. 16 gram per mole. Sulfur, 32. 32 U. 32 gram per mole. Wherever we have written this U, what does it actually mean? This number multiplied by this constant number. Correct? I hope the concept of atomic mass is very clear. Let us solve one problem about this in MCQ form. Relative atomic mass of sodium is going to be how much? Relative atomic mass. This is nothing but relative atomic mass RAM, which is nothing but simply number of nucleons and no unit after that. No unit. By the way, sodium is Na with 23. So out of this, you can clearly see the answer is 23. And no unit should be written. By the way, if you check the other answers, what is this? This is going to be gram atomic mass. Isn't it? We write it with gram. What is AMU? This is simply going to be atomic mass. And kilogram would be in case you report it as kilogram. So this is going to be our relative atomic mass. Go ahead, let us see one more question. Calculate the total number of atoms in 52 U of 4 He atomic sample. First of all, from here, what do we understand? We understand one atom has a weight of 4 U. What I'm speaking about is atomic mass because the unit is U. They are asking us 52 U will contain how many such atoms? Now, this is a simple mathematics. It's 52 divided by 4. That's going to be 13 atoms. So they are asking us number of atoms to calculate. After taking atomic masses, let us go for more useful concept, and that is molecular mass. Molecular mass is basically simply sum of all the atomic masses of that molecule. So if I just take a proper example, proper sentence of a procedure, it is multiplying the atomic mass of each element by the number of atoms, adding them together later. So in case you are looking at simply a molecule of water, it has hydrogen's atomic mass given to you, multiplied by 2 hydrogen. Oxygen's atomic mass given to you multiplied by 1. Answer becomes whatever given to you. These atomic masses are usually given to us in exam, so you don't have to be worried about it. Let us practice some questions after using the table from your synopsis. You can refer to the things. So carbon, as you know, we are going to use the standard numbers here. So carbon is 12. There are 2 oxygen with 16. So this is going to be 12 plus 32. That will be 44 U. In case you're writing the same answer in gram per mole, the gram atomic mass, simply change the unit. Let us solve. Carbon 16 plus 4 times hydrogen. Oh, I'm so sorry. Carbon is 12. By mistake, I wrote 16. So carbon is 12 plus 4. That's going to be 16U. In terms of gram atomic mass, it will be 16 gram per mole. Hydrogen's mass is 1, and there are 2 hydrogen with oxygen mass 16. So total mass become 18U. In terms of gram atomic mass, it's 18 gram per mole. 2 hydrogen, each hydrogen 1. 2 oxygen, each oxygen 16. So it's going to be 32 plus 2, 34U, or 34 gram per mole. Carbon is 12, oxygen is 16, 28U, or 28 gram per mole. We are considering, those particular examples which they usually ask in most of the exams. So this is a good practice for you. Hydrogen 1, nitrogen 14, oxygen is going to be 48, 16 into 3. So this is going to be 63U, or 63 gram per mole. As I usually tell you in my other videos, if you're solving problems, better you pause the video, you do it on your own, and then better check the answers. 2 times carbon, 12, plus 6 times hydrogen. So this is going to be 30U, or 30 gram per mole. Nitrogen 14, hydrogen 4 into 1, plus chlorine 35.5. This total comes as 53.5U, or 53.5 gram per mole. Coming to calcium carbonate, calcium 40, carbon 12, oxygen 16 into 3. So it's 40 plus 12 plus 48. This becomes 100U, or 100 gram per mole. Next comes to sulfuric acid. So it's going to be 2 into, so it's going to be 2 into 1 plus sulfur 32 plus oxygen 16 into 4, that's 64. So the overall molecular mass becomes 98U, or 98 gram per mole. Correct? Going ahead, some more practice. Nitrogen 14, hydrogen 3 into 1, that becomes 17U, 17 gram per mole. Sulfur 32, oxygen 2 into 16, that's 32. So becomes 64U, 64 gram per mole. Potassium 39, oxygen 16, hydrogen 1. So that makes it 40 plus 16, 56U, or 56 gram per mole. Two examples more of organic molecule again here. C6H12O6. Carbon is going to be 12 into 6. Hydrogen 12. Now you need to multiply oxygen by 6 number. So that's going to be 16 into 6. That's 96. So 96 plus 12 plus 72. Glucose molecular mass 180 or 180 gram per mole. Next, 6 carbon 72. 5 hydrogen 5. Chlorine 35.5. So it's 72 plus 5 plus 35.5. Total is 112.5 U or 112.5 gram per mole. I hope the practice is good. Let us do some other type of problems. These are your MHT-CET level questions and see if you can answer them. First, calculate the molecular mass of copper sulfate pentahydrate. First of all, what are we looking at? Which molecule is it? It is CuSO4 dot 5H2O. So we need to take the atomic masses of all these elements, considering copper mass and so on. So let us begin. Copper is 63.5 plus sulfur is going to be 32. Oxygen is going to be 16 into 4. That's 64. Plus water's individual mass is 18, H2O. Multiply by 5 is 90. So this is component of water we are writing. I hope this calculation is understood. So we just need to do a total of this and that will be our answer. So answer comes as 249.5 U or 249.5 gram per mole. Whatever unit they ask you in exam. Another one, next substance they have given is sodium carbonate, which is Na2CO3, decahydrate, 10H2O. Once again, water's molecular weight 18. This is 10. So water's component is 180. Sodium itself is 23. So 2 sodium will become 46. Carbon is going to become 12. Oxygen is going to become 48. And water's component we have already seen 180. So do a total of this. You will get 286 U or 286 gram per mole. Just to review the concept again, this mass we have written is called gram atomic mass. And when they say, or in this case, this will be gram molecular mass. And this will be just written as simply molecular mass without the unit gram. Let us practice one more question of this format. They have given a big compound to you called Mohr's salt. Now, different masses are given over here. So, iron's mass is 56 plus sulfur is 32 plus oxygen is 64. What I'm going to do is calculate the 3 components separately and then add them up. That should go a little easy. So this is 56 plus 34, 32 plus 64. This much component comes out to be 152. Now think about NH4. Nitrogen is 17. Hydrogen is 4. So this becomes 21, 17. I am so sorry. Nitrogen 14 plus 4. That makes it 18. Outside multiply by 2. That makes it 32. Sulfur 32. Oxygen again 64. So this is 36 plus 32 plus 64. That's 132. Now comes water. Water is going to be 6 into 18. That is 108. So finally, we have a big total to do. 152, 132, 108. So 132, 152, 108. Molecular weight comes out to be 392 U or 392 gram per mole. Whenever you have a little bigger salt, it's always better to solve it separately, then add it up. That gives you an answer much more easily and of course without a bit of errors. Let us go ahead. More questions. Molecular mass of oxygen will be how much? Again, revising the concept. They are asking molecular mass. So the unit has to be U. And that's why you can see answer will be 32. Those who are thinking this is the answer, this is actually gram molecular mass and not molecular mass. Understand the difference again and again. Let us see whether you can understand bit of a tricky question. Calculate the total weight of 10 molecules of butane. First, what is the mass of one molecule of butane? Let us find that. So it's C4H10. So it's 4 into 12 plus 10 into 1. 48 plus 10. That's 58 U. This is for one molecule. Now they are asking me for 10 molecules. So obviously multiply by 10. Answer should be 580 U. Correct. Going ahead. A new concept which is introduced over here. But frankly speaking, we make use of it not that much. You know, up till now, we had considered all the molecules, which were all organic molecules or also known as covalent molecules. Now, if you have compounds which are inorganic molecules, ionic compounds, such as sodium chloride, potassium chloride, zinc oxide, potassium nitrate, zinc sulfide, calcium fluoride, and so on. You know, they do not exist as separate molecules. They exist as a group of ions. The condition is such that each ion is surrounded by certain number of oppositely charged ions. Let me prove it with an example. This is a real life diagram of sodium chloride. Now, if you observe, the yellow circle, what you see here, is of sodium. So, watch any sodium ion, for example, this one. And you can see it is being surrounded by 1 chlorine, 2nd chlorine, 3rd chlorine, 4th chlorine, 5th chlorine, 6th chlorine. So, you know, each ion of sodium is being surrounded by 6 chloride ions. If you check in a similar manner a particular chloride ion, you will see that also is surrounded by 6 sodium ions. So in such case, for ionic compounds especially, instead of molecular mass, they use a term called formula mass. There is no separate method of calculation. Please understand. The calculation is done in a similar way, only it is a term which is different. So let us try our examples again. Sodium 23, chlorine 35.5. So the answer I am writing will be 58.5. Correct? We will keep it for simplicity here in U only, nothing else. So calcium 40. sulfur 32, oxygen 4 into 16, that's 64. That total comes out to be 136 U. Once again, going ahead, calcium 40. 2 chlorine atoms and each chlorine is 35.5. So that's 40 plus 71, 111 U. Copper is 63.5. Now let us calculate NO3 a bit separately. Nitrogen is 14. Oxygen is 16 into 3, that's 48. And this number 62 is 2 times because it's NO3 twice. So it's 62 into 2, 124 plus 63.5, that comes out to be 187.5 U. This is the way we calculate formula mass. Nothing different. Just instead of molecular mass, call it formula mass. Very simple, very similar concept. After formula mass, let us go ahead to another small concept called average atomic mass. As you know, most of the elements, rather almost all the naturally occurring elements, occur as one or more than one isotopes. So when so many isotopes are present, how can you report an atomic mass? For that, they found out a method called average atomic mass. For that, they use a very simple formula. Percent abundance into isotopic mass of all isotopes summation divided by 100 gives you isotopic mass. Let us prove it with an example. Suppose chlorine isotope 35 exists at 75% in nature. Another isotope 37 exists in 25%. So the calculation is simple. 75 into 35, first isotope. 37 into 25, second isotope, divided by 100. This gives you the answer 35.5. Perhaps now you will understand that in periodic table, when they write atomic mass of chlorine as 35.5, from where have they got this? This is the way scientists do the calculation for all the known isotopes. Let us solve some problems based on this concept. First one, boron 10 and boron 11 are existing in these manners, in these percentages. Let us calculate the average atomic mass. So average atomic mass will be given by formula. The isotope 10 existing as 19.1. Isotope 11 existing as 80.9. The whole thing divided by 100. 19.1 into 10 is 191. This multiplication comes as 889.9 upon 100. So if you do the total of these numbers, it comes out to be 90801. So dividing by 10, you will get an answer 10.809 U. This is the average atomic mass of boron. A quite straightforward problem, you can see. Let us make it a bit complex with another question. Read it, think over it, then pause the video, think, and then you can see the solution. Average atomic mass has been given to you. 2 isotopes masses are there. We have to calculate their abundance. So we will say, let abundance of one of the isotopes of, let us say, 22x is taken as x. So naturally, the abundance of 20x is going to be how much? 100 minus x. Because total abundance needs to be 100. Now, using the equation of average atomic mass, in this case, you know the answer, 20.426. The atomic mass of first isotope is 20.18 multiplied by X plus second isotope 19.95 into 100 minus X. The whole thing divided by 100. If I multiply this ahead, I will get 2042.6 equal to 22.18x plus, opening the bracket, first number will be 1995 minus 19.95x. Now, clubbing this number together along with the x number separately. So you will get 2042.6 minus 1995 equal to 22.18x minus 19.95x. So if I separately subtract them, we will get an answer of here 47.6. And here it becomes 22.18 minus 19.95, that's 2.23x. So now if I divide it, this number, the X answer comes as 21.34% and the other will be 78.66%. So this gives you the abundance of both of them. So if I just report this 21.34 will be the percent abundance of this isotope, and this will be the percent abundance of second one. Let us solve this question, which was a PYQ of NEET 2007. These are the options given. Now you can solve this method by a regular question also. Like, for example, we can find the average atomic mass as, if I substitute, it's going to be 200 into 90 plus 199 into 8 plus 202 into 2, the whole thing divided by 100. So if I take up all these numbers, 200 into 90, it's going to be some big number like 18,000 plus 199 into 8. It's going to be 1592. And this is simply going to be 404 divided by 100. So if I just add up all these big numbers, it will be 18,000 plus 1592 plus 404 is 19996. So after calculation, the answer is 199.96 Joule. If you consider all these numbers, your answer should be actually 200 Joule, because 199.96 is not mentioned anywhere. Rather, if I apply the rounding off rule, this number is greater than 5. I add 1, that makes it 200. Now let me come to a shortcut, and that is what is expected and not this kind of solving in exam like NEET. Some of you might have guessed that thing. The isotope which has the highest abundance, take that as atomic mass, and that is your answer. So the number highest 200 belongs to 90% of population of atoms. Obviously, that is going to be the answer, and no need to solve in such a great depth. Let us go ahead and take up one more concept as valence electrons. For valence electron, they can give you an atom. You can write its configuration. For example, hydrogen's configuration is 1, Carbon is 2, 4, nitrogen 2, 5, oxygen 2, 6. So where are the valence electrons? Hydrogen has only one valence electron, while carbon has 4, nitrogen has 5, oxygen has 6. Okay, based on this, what kind of question we get? A nitrogen molecule will have how many valence electron? Oxygen might have how much? Water might have how much? So now let us come back. Nitrogen, one single atom, has 5 valence electron. So N2 is going to be 5 into 2, that's 10 valence electron. Single oxygen has 6. So in the formula, there are 2 oxygen. So it's going to be 12 valence electron. In hydrogen, it's 1 valence electron, but there are 2 hydrogen present. In oxygen, there are 6. So it's going to be 8 valence electrons present. I hope the concept is clear, provided you know the electronic configurations of the atoms. Let us solve one last question on this. Calculate the total valence electrons in 50 molecules of carbon dioxide. So, some prerequisite. Carbon 6, configuration 2, 4. Oxygen 8, configuration 2, 6. So, carbon valence electron 4. Oxygen valence electron 6. There is one more oxygen atom. So this is going to be 16 valence electrons which are present in one molecule, in one single molecule. They are asking me 50. So 50 molecules will contain 16 into 50. 16 fives are 80. So 800 valence electrons. I hope today's concept of atomic, molecular and formula mass is clear. This topic is going to be the very foundation of our most important next lecture, known as mole concept. Study this very well, and then we will enter into the jungle of mole concept next week. Thank you.